In this lesson, we are going to learn how to describe the location of an electron in an element. But before we can do that, we need to look at the periodic table to find where the sublevels and the energy levels are, or how to determine the number of electrons in a sublevel of a specific energy level. Now, this periodic table is color-coded based on the sublevel, and again, there are 4 types of sublevel: S, P, D, and F. This is where all the S sublevel are located, in addition to heliums over here. And then in the middles, we have the D sublevel, and then over here, we have the P sublevel. Okay, and all the way on the bottom, we have the F sublevel. So based on the location on the periodic table, you determine the specific types of sublevel that the electron is located in. In addition to the sublevel, we have the energy level. Now, the energy level is defined by the period number. For the S and P sublevel is defined by the period number. So, for instance, if I look at carbon, which is in the P sublevel, carbon is in period 2, so therefore it has the energy level of 2, specifically for that electron right here. Okay? And then for the D sublevel, is defined by the period number -1. So if I look at chromium right here, chromium is in period 4, so 4 minus 1, that will give us, so the electrons right here for chromium is in energy level 3. Now lastly, we have the F sublevel, which is the period number -2. So we look at uranium right here, which is in period 7, 7 minus 2, that gave us 5. So the electron right here is in energy level 5. The last part is the number of electron. The number of electron is based on the number of boxes on the periodic table. Each box represents one element, which is equal to 1 atomic number. Therefore, it's also equal to 1 additional electron. So 1 box is equal to 1 electron. Now, how do we write an electron configuration? First of all, we always starting from the lowest energy level. Okay, so we're starting from hydrogen, which is energy level 1. But where do we stop? We stopped at the location of the element that we want to write the electron configuration for. In this case, let's look at chlorine right here. So chlorine is right here, but we start from the very beginning, which is at energy level 1. So we would write 1. And what sublevel is it in? It's in the sublevel S. So we have 1s. How many electrons does it have? In this 1s sublevel, 1, 2. So we have 2 electrons. Notice I grouped the electron together because this electron belongs to the sublevel S of that specific energy level 1. So we continue. There's nothing else to write about 1s2. So we move on to the next period. So in this case, the energy level changed to 2. So we write 2. And it's in sublevel S, so this S belongs to energy level 2, and it has 1, 2 electron. Now, there's no more electron to include in the 2s sublevel, so we move across. Then we have the P. Now, this P, again, the P has the same energy level as the period number, which is 2, so we have 2P. And in this 2P, there are how many electrons? Going back to the idea that one box is equal to 1 electron, we have 1, 2, 3, 4, 5, and 6. So we have 6 electrons in this 2p. Then we keep going because we are not at the chlorine element yet. So we have to continue until we get to the chlorine. Now going down, we have the S sublevel is in period 3. So in this case, we write 3s. And how many electrons are there in this 3s sublevel? 1, 2. So we put 2 there. Next, we go across and we have the P sublevel in energy level 3. Again, the P and the S has the energy level represented by the period number. So we have 3P, and how many electrons are there in this 3P? 1, 2, 3, 4, 5, 6. But chlorine is right here, so we stop at the 5th electron in this 3P. So we have 3P5. And that is all we have to do when it's writing electron configuration. This right here is also the 5th electron in the P sublevel, also is the last electron. So by looking at the last electrons, we can also find the element on the periodic table, because chlorine, the last electron of chlorine, is specifically defined by 3p5. Okay, if we are looking at bromine right here, it would be defined by its last electron, which is in energy level 4. Okay, for bromine right here would be energy level 4, and it's in the p sub level. So 4p is in the 1, 2, 3, 4, 5, or the 5th electron. Let's say if I look at titanium right here. So titanium is, let's look at over here, titanium. Titanium is defined by its last electron, which is in energy level 3, because it's in period 4. 4 minus 1 give you 3 right there. And it's in the d sub level. So therefore, 1, 2. So it's in the second of the d sub level. So again, by looking at the last electrons on the electron configuration, we can determine the elements for that electron configuration.